Hi guys, hope you're fine and doing well. So today we will be discussing this problem from the LeetCode, which is Stone Game. So this is the 18th problem of the dynamic programming series. So if you haven't watched the previous videos, you can consider watching them since it will be really helpful for you to understand the concepts in the upcoming videos. And in case you are new to this channel, you can consider subscribing it and pressing the bell icon so that you don't miss any of the upcoming updates. So let's get started with this question. So, the question name is Stone Game. It is also popularly known as optimal game strategy in coding community. So, let's read the problem, what it tries to say. So, the question states that there are two players, which is Alice and Bob. So, they are playing the game of piles of stones, and there are even number of piles that are arranged in a row, and each pile has a positive integer which represents the number of stones in that pile. So the objective of the game is to select the stones such that any of the person ends with whoever ends with maximum stones simply wins the game. And the total number of stones is odd so that there are no ties. So first turn is taken by Alice, and the condition is that how can we choose the stone is that either we can simply choose a stone from the first or from the last. So this is the constraint in this problem, and after all these combinations we are required to find out in case the Alice wins the game, then we have to return true, and in case the Bob wins we have to return false. So let's have a look at a test case and analyze how the answer will build up. So firstly, like, these are all the piles that are given to us, and the integers are representing the total number of stones in these piles. So let me consider Alice and Bob. So firstly, since the turn is of Alice, so first approach that may come up to your mind is that to make any one of them win, we can simply choose the maximum, because in the question it is written that both play optimally. What does it mean? That when it's a turn of Alice, she also tries that I won't let the Bob win, and when it's Bob's turn, so he also thinks that I won't let Alice win. So since both of them are playing optimally, so the one solution that may come up is that let both of them select the maximum number of stones that they can. So since the first turn is of Alice, so she has two options. Either she can choose one or she can choose four. So in case she chooses four, so the number of stones that are left is 1, 3, and 7. So out of this, the total number of ways in which Bob can choose is only two, and those are 1 and 7 stones. So what will the Bob choose? So Bob will likely choose 7 because he wants that he should win and Alice should not win. So now the stones that are left is 1 and 3. So only option with A to choose is the maximum out of both of them, which is 3. So Alice will be choosing 3, and only the last stone will be left, so it will be taken by Bob. So if we clearly see, the total number of stones that are with Alice are 7 and with the Bob are 8. So clearly in this case Bob wins. But the problem in this solution is that it is not correct. And why it is not correct? Because Alice has not played this game optimally. So let's see how Alice can play this game optimally so that she doesn't allow Bob to win. So this is Alice and Bob. So firstly, since she has two options out of these 1 and 4, so let's say this time she chooses 1. So the total number of stones with Alice is 1, and now these three piles are left, and choices with the Bob are either he can choose 3 or he can choose 4. So out of them, he'll try to choose the maximum one, which is 4. I'm just taking it randomly. So in this case, what will the Alice choose is, because only two piles are left, so this case Alice will choose 7. And in the last, oh sorry, I just wrote 4 here, so obviously these two elements should be left. So yes, out of these two, Alice chose 7, so the only element left is 3. So Bob will be choosing this 3. So if we now total this, it comes out to be 8, and this Bob comes out to be 7. So in this case, Alice is winning. So the actual answer for this test case should be true, because this is the case where Alice has won the game and played optimally. So now let's have a look how can we approach this problem in a brute force manner. So just let me clear this out, and the numbers that we were given were 1, 3, 7 and 4. Yes. So the first thing that we should think is, the first part that we need to maintain is the range. Like we were selecting this range, or the total number of stones that were left for these. So this is the range that we every time need to keep a track of, so that we can just analyze like which pile we need to pick. And the second thing that we need to keep track of is, whose turn is it? Like, is it Alice's turn or is it Bob's turn? So these are the two things that we need to focus upon while building our solution. So let's create this function. So our function will look something like this, and we will be given our array, and we will be given int left, int right. So L and R represent left and right. And the second thing is, I'll take this boolean variable b. So in case this b is true, then it is Alice's turn, and in case this b is false, then it is Bob's turn. Yes, so this is what we are required to find out. So the other way of looking at this problem is that we do not need to find out like what is the maximum number of stones that Alice can get or the Bob can get. So what we can think of is, we can simply find out maximum number of stones that Alice can have. Alice can have. So if we know what are the maximum numbers of stones that Alice can have, we can simply add all of these stones. So the total minus the count of stones of Alice. So these will be the stones that will be with Bob. Obviously, that will be the maximum stones that Bob can obtain. So let's see how we can implement this idea. So let me just clear this out. Yes. So firstly, we'll in this function, we'll write if this b is equal to true. In case it is true, what we will do is, we will simply return maximum of max of, and what will this maximum contain? So the first term that it will contain is, I am writing these two terms here. So the first term will be basically function of a L plus 1 and R, and then since it is this turn is true, which means that this turn is of Alice, so next time it will be changed to false, plus a of L. So what does this mean? In case like this was the range and this represents L and R, so Alice chose simply 3, and next time the next range will be 7 and 4, which is L plus 1 to R. And false. Why false? Because in this range only Bob can choose. So that is the reason I just put false there and just incremented the range. So first is this, and the second part here is same function a L R minus 1, and again it is false plus a of R. So this time we are just considering that if this was the range, then Alice chose 4, and the new range that will become is 3 and 7, and that too Bob will be choosing from this range, so hence next time we will be passing false in this answer. So out of this 1 and 2, Alice will be choosing the maximum answer that will come out of these two values, and simply returning it. And now in case the turn is of Bob, so what will he do is, logically thinking, we may think that here also for the Bob it will simply be max of this 1 and this 2. Just this false will become to true, and this a of L and a of R will be cancelled, because in this particular case we are simply calculating the maximum number of stones that can only be obtained by Alice, not by Bob. Because if we want to calculate for the Bob, we can simply just summation all the stones and just subtract the total number of maximum stones of Alice. So we will get off Bob. So that is the reason we are just not incrementing this A of R and A of L in this case, right? So this is what we may think of and simply return our answer. But here the problem is that Bob is also returning the maximum answer out of these two after selecting. But if we think it in like this way, that if you and I are playing, if you choose the maximum stones that are there, and I have some range, and out of that range, I have two possibilities. Either I can select the first or the last. And after selecting that, what will be my approach? My approach will be obviously to return the minimum number of stones that you can choose. So not the maximum number of stones. Hence, in this case, it should be minimum, not maximum. Because Bob's approach will always be that he should return the minimum number of stones that Alice can choose, not the maximum number of stones that Alice can choose. So this is how we can code this problem. So let's code it and see is our answer correct or not. So I'll just change this piles to A and create a function public int function, and this A int L int R and boolean B. So this B states that in case B is true, in case B is true, then it is Alice's turn, and in case this B is false, then it is Bob's turn, right? And what is the base case that we will be putting is if L is greater than equal to R, we'll simply return 0, right? And the next what we will do is if B is equal to true, this is Alice's turn, and or else it is Bob's turn, right? So let's create these two functions, and f1 is equal, let's create the value 1. v1 is equal to function of a of L of R and not of B, and similarly this value 2, and in this case I'll just increment left range to 1 and I'll reduce the right range to 1, in this case v2. So now what we will do is we will simply return math.max out of v1 plus a of L and v2 plus a of R. So out of these we will simply output the maximum number of stones, and in this case is very important. It may even confuse you. You can just think it like that if you are just doing math.max here. So what does it technically mean? So it does mean that after Bob has selected the total number of stones that he requires, he's just letting out the Alice to choose again the maximum number of stones. But in this case, Bob is not playing optimally. To play optimally, he has to leave minimum number of stones that Alice can choose. So that is the reason we will be putting math.min in this case. So it will simply be v1 and v2. We are not incrementing a of L and a of R here because as I told previously also that we are just calculating the maximum number of stones that Alice can obtain from here, not Bob. So we will just subtract the total number of maximum stones out of total number of stones that are given to us. We will just simply subtract the total number of maximum stones that Alice can have. So this will give us the total number of stones of Bob. So we'll simply return in this case, and let's call this function. So I'll create a variable int stones underscore Alice. So these are the stones that Alice will have, which are function a, L is 0, R is a dot length minus 1, and this will be true. Why true? Because it is given in the question that Alice will be starting the first. So that is the reason I have taken true here. And let me just create a sum variable to find out the total number of stones, which is sum plus equal to a of I. So in this case, we have got the total number of stones that Alice has, and to find out the stones for Bob, stones Bob is equal to, which is sum minus stones of Alice. So this is the stones that we have got for Bob, the maximum number of stones that Bob can have. So in case the stones of Alice is greater than stones of Bob, then we will simply return true. Or what we will do is, if that's not the case, we will simply return false. This means that Alice won, and in this case, what does it mean? Bob won the game. So now let's run our code and see if it is correct. So yes, it is working correctly. So now let's try to submit this. So it is giving time limit exceeded. So the reason is, let's have a look at the reason. Yes. So the reason is that the length of the pile is 500. So for every turn, there are almost two options. So it will be something of the power 2 to the power 500. So which is obviously out of the range. So now let's have a look. How can we optimize our approach? So to optimize our approach, just let me just clear this out. Let's suppose that we are given this A, B, C, D, E, and F. So in this test case, since we have operating on this range, then the two functions that we will call are, for one is for this range and the other is for this range. So once these two functions are called, which are mentioned here in these two lines, so after these are called, now for the blue function that is being called, in case A is selected, then the range left out will be this. And in case for the orange range, F is selected, then this will be the range that we need to operate upon. So we are calculating this two times. So similarly, when all the ranges are considered, so there will be lot of ranges that will be being calculated again and again. So this needs to be avoided. So to avoid it, because range deals in two variables, which are namely left and right, L and R. So this is two-dimensional DP problem. So we will be creating a 2D array and simply just initializing L and R indices with the answer of their particular range. So now let's do that. We'll simply pass in DP array and we will just write if DP of L of R is not equal to 0, what we will do is we will simply return dp of L of R, which means that we have already calculated for this range. So we don't need to repeat it. So in this function, we will just parse dp, and here we will initialize it with L and R is equal to math.max, and here dp of L of R is equal to math.min. Yes. Now just let's parse this dp array in this function too, and the length will be a dot length, because the maximum length of L and R can be the size of the array that we are given. Now let's try to run this if it is working. So this is working correctly. Now let's try to submit it. Yes, it is working fine. So I hope you understood solution in this video, and if you appreciate my work, you can consider subscribing to my channel and giving thumbs up to this video. So let's meet in the next video. Till then, bye bye.